Hi everyone. Again, we are going to be looking at another topic in mathematics, which is understanding set theories and linear diagram. So, under this topic, we have interactive content, which will serve as a guide for this class. So, now, what is a set? A set is the collection of a well-defined mathematical objects or things which are called the members or elements of that set. So when you're talking about set, when you have a well-defined objects, thing, materials that are properly well arranged, then we can refer to such as what? As a set. And for a set, every item or every object or thing that is well arranged can be called members of the set or an element of that set. The set can consist of elements of various alphabets, people, physical objects, numbers, sign, symbols, etc. So set can be, contains so many elements. You can have alphabet like A, B, Z to Z. You can have people, we have tall, short, fat, slim, physical objects like we have pencil, we have book, cleaner, numbers like 1, 2, 3, signs like plus, minus, with symbols like minus, division, multiplication, and code. So if you arrange them in a proper way, then we can refer to such as a set. Now we have an example that is being shown here. See, zombies are no emotion robots, eat flesh, airlines, high techniques. Then all of these we can say that it kills humans. So if you want to refer to this type of set, we can refer to it as set that kills all humans. Then we can actually be referring to all of what we have there. So like something like emotions, we can have all of this that we have here. Now, that will lead us to how to identify an element of a set. We have made mention of it that element is what? Is every item in a given set. So now an element can be specified by listing all its members. So if you list every members of a set, then you can actually identify that set. So for example, assuming that I have something like A, B, Z to Z, that type of set is what? A set of alphabet. So we can list all the member of the set. So with that, we can identify a set. Now, a defined set of rules which generate its member or by giving a property of its element. Now, for example, here we can have something like an even number. So we said that, okay, let's set P be all even number that is between 1 to 20. So if you have to mention that, that implies we can have, what are even numbers? Even numbers are numbers that can be multiplied by what? By 2. So we can now have 2, 4, 6, and it goes like that until we get to 20. So we can identify a set by a specific rule that generates its member. So if you have, for example, that, okay, let's see, this is set Z. We have 2, 4, 5, 6, 8. And so each number of this set, we call it element, and it can be denoted with n into bracket set Z, which is what we refer to it as numbers of elements in set Z. So if you count how many numbers are this, we have 1, 2, 3 elements in set Z, 5 in numbers. So let's check our arrangement. Yeah, that leads us to the next activities there, which is type of set. We have different type of set. The first one here we are talking about universal set. Now assume that we have set A, we have 1, 2, 3, 4, 5. We have set B to be 7 and 8. Then mu is said to be a universal set of A and B if set A and B are found in mu, which is universal set. So if you can find set A, which is 1, 2, 3, 4, you can find set B, which is 7 and 8 in universal set, then we say that set A and B actually are a universal set of what? Of mu. So which can be denoted as mu, or we can have it as epsilon, so which is the sign. Now for empty sets, empty or null set, you can call it empty set, you can call it a null set, is a set is said to be empty is if it has no member or no element. So if you have a set that is that contains no member or element, then we refer to that type of set as an empty set or a null set. So, and we can denote it as phi or open and closed bracket. Now we're talking about finite set. This is a type of set which has a well-defined specific object and they are discrete in nature. So they are specified, something like I have a set of 8 to be 1, 2, 3, 4, 5. So within that set, what are the members that you have there? We have 1, 2, 5. So they are discrete in nature and that gives a finite set. Now let's look at it. Now this diagram here denotes a universal set. Under this, these are just examples of quadrilaterals. We have hexagon, nonagon, pentagon, hexagon, and octagon. So this view here is denoting that all of these angles that we have here are actually universal sets, while A and C are sets that can be found in the universal set. So that leads us to the next type of set that we're looking at, which is infinite sets. It's a set that are continuous in nature and are not specified. So one thing about finite set, we can say that numbers, example is a number. We can look at this place. We have example of finite set to be natural number. You know, natural numbers, they are continuous in nature. They doesn't have a limit. So they are continuous in nature. Now, for another one, we can make mention of real numbers. What are real numbers? I have made mention of that before, that real numbers contains what? Both rational numbers and irrational numbers, where you can have your square root, your decimal point, and also fractions. And look at this example too. Real numbers that are between 0 and 4. So all these type of illustrations are what? They are universal sets. We are mentioning the numbers that are between 0 and 4. We can have decimal points, we can have fractions, we can have so many things. So it's a continuous type of set. So now, when we are talking about subsets, when let's cite an example, set D is called a subset of set C if all the elements in D can also be found in set C. So if we have all elements in D, for example, I can find other elements as well in C, then we say that D is a subset of C. That leads us to another type of set, which is equivalent set. Now, given A to be, that is set A, X, Y, and Z, and we have B to be 1, 2, 3. So if the numbers of elements in set A is equal to the number of elements in set B, then set A and B are equivalent sets, and we can denote that as this. So when you have the same numbers of elements in 2 or 3 type of sets, then we call that type of set equivalent set. Then we have segment sets. This is a type of set with only one element. So we have only one element consisted in that type of set, and we have an example here. Given set D, it contains just one element, which is 4. Now we have equal sets. If you have 2 type of sets that have the same type of elements in them, then we refer to that type of set as equal set. Now let's look at this illustration we have. If you look at it, this is A, B, C, and D. And if you look at set B as well, we have B, C, D, and A. So if you look at set A and set B that we have here, you see that they have the same elements in each of them. So we can refer to this type of set as what? Equal sets. Whereas if you look at this other example here, we have 1 to 4 in set A and A to D in set B. So if you look at this type of sets, they have the same number of what? The same numbers of elements. So we refer to this type of set as equivalent set. So that leads us to set operation. Under set operation, we are going to be looking at union of the set and intersection of the set. So when you're talking about union of the set, you are assuming that we have a set. Let's say we have set B and we have another set, we have set C. So if we are talking about union of the set, that implies that you are bringing all the elements in set A, B, and set C together. So by the time you bring all the elements in set A and set B and set C together, then we refer to that type of set as what? As a union of a set. So if you look at, we have an example here. This is a set which is set A. This is another set which is set B. So sets this one is giving us that we are bringing all the elements in set A and we are bringing all the elements in set B together, and we refer to this as what? A union B, and this is the sign for union. So let's try to rearrange this. It is being denoted as what? B union C, and it means that we are trying to bring both elements in set B and set C together. So that is what we call union of a set. So let's check. Okay, now that leads us to an example here. We are going to be solving this example together and we'll be deriving the solution. So let's solve this example and let's see what we have. Okay, we have this set here. You see, this is set A. And set A comprises of 2, 4, 6 through 20. So these are even numbers. Set B is a natural number from 1 to 8, while set C, we are additions of 3. That makes a set C. So we are looking for a union of A and B. So A union B. What that one is trying to tell us that you are bringing set A and set B together. So you are bringing all the elements in set A and set B together. So if we have that, you look at it, we have 1, okay, we have 2. After 2, what else we have in set A and B together? We have 3, we can see 4, we have 5, we have 6, we have 7, we have 8, we don't have 9, right? So we have 10. After 10, we have 12, we have 14, we have 18, we have 20. So if you look at it, A union B means that we are bringing all the elements in A and B together, and that makes A union B. So for A union C, what are we going to have? We have A union C. So that implies that we are bringing all the elements in A and in C together. So let's have what we have here. We have 1 in C, 2 in A, and we have 4 together. So we are writing just 1 4, not the 2 4. So we have 7, we have 8. After 8, we have 10 together. So we are just writing one of the 10. We have 12, we have 13, we have 14 in A, so we have we don't have 15 in both of them, but we have 16 common to both of them, so we are writing just 16. After 16 we have 18, after 18 we have 19, and that makes what? A union of C and this. So with that we are going to be picking up the answers for this one. A union B is going to be what? We are going to be having this as A union B, and for A union C, okay, we have 20 in C, so we have 20 should be inclusive here, so we have 20 here to be A union C. So 20 is also in if you look at it, we have 20 here which is in A, so 20 will be in A union C. So we have our A union C to be this, and that gives us the example. So let's quickly, we are going to be dragging our answers to each boxes. Okay, so let's drag. So for this one, we are going to be dragging this because this is A union B, and for the other one, this is A union C. So that's it. Let's check. So, okay, now that leads us to what? Intersection. When you are talking about intersection, you are trying to see that what is common between two given sets. That is what we call intersection. Let's assume we have a set B and we have a set C. So common element in the two sets is what we call intersection. So this leads us to what we have here as an activity. We have a given set A. This is made up of even numbers of 2. Additions of 2 to each of these will give us set A. Set B is the natural number of 1 to 8, and set C is an addition of 3. 1 plus 3 will give us 4, 4 plus 3 will give us 7, 7 plus 3 will give us 10, and that's how we run this set C. So under this first one, we are finding what is what? A intersection B. Now let's look at it. A intersection B, what is common between A and B? Let's look at what is common between A and B. 2 is common, right? So we have 2. After 2, what else is common between A and B? After 2 is common, okay? So we have 2, 4 is common, so we have 2 and 4 now. Let's check, 6 is common, we have 6 and 8. So for A intersection B, the element is going to be 2, 4, 6 and 8. So that is what is common between the two sets. Now for A union intersection C, so let's look at what is common with A and C. The only two values that is common between A and C is what? 4 and 10. So A intersection C is going to be what? 4 and 10. That's going to be the elements in there. So, okay, now that leads us to our past question. So we are going to be looking at this past question. What is it telling us? Look at this shaded information. What is this showing us? What can you say about this? This is that we are having a set A, we have set B, but this is being shaded, so that implies that we are having A intersection B. The shaded part is indicated. These are the elements that is actually common to A and B. So we have this as what? A intersection B. Now let's look at the next past question that we have here. It's telling us that we should highlight all the elements in A and C. If you look at the set that we should find N intersection C, which is, it means that all the numbers of elements in A and D. So let's bring all the numbers of elements in A and D together. That is what we are doing here. We are bringing elements in A and D together. So from there we have B. After B, what else can we have in these elements? We are bringing the two elements together. So after B, we have what? We have D. So okay, we have B. After B, we have F. After F, we have G. After G, we have H. After H, we have what? H. After H, we have J, right? After J, we have K. Then after K, we have what next? After K, we have M. Then after M, we have P. After P, we have Y. That's what we are supposed to have after P. So by the time you count all the elements, it makes 8 elements together in this universal set. So let's check. And this leads us to the end of our class. We want you to subscribe to our channel www.edubbey.com for full interactive content of this class. Thanks for listening.